Alright guys, well a system of equations, we've talked about this a little bit already. A system of equations essentially is just two or more equations. And oftentimes what you're going to be doing is looking for values that will make all of the equations true at the same time. What does that mean? Well, let's imagine that we have two equations. And I'm just making these up right now. So let's say we have y equals 2x plus 3 and y equals negative x plus 6. Okay, well, so we combine those system of equations with this bracket, and if we think about graphically, well, each equation gives us an infinite set of points that make that respective equation true. So if I think about this equation here, this is describing an infinite number of xy points such that twice of x plus 3 is y. If I were to graph that, I can graphically represent the collection of all of those points. So it has a y-intercept of 3 and a slope of 2, so it goes up 2 and over 1. So I'm going to get a line that looks something like this. And if I wanted to graph the second equation, well, now we've got a y-intercept of negative 6, and it has a slope of negative 1, so we're going to go down 1 over 1, and we get some line that looks like this. So what we see is that while this equation has an infinite number of points, and this equation has an infinite number of points, think about just all of the different points that make up that line, there's a unique point that makes both of them true. And that unique point is 1, 5. And we can see that because graphically it's at 1 and 5. And if you wanted to, you could graph this on Desmos or other graphical software and find that intersection. So what we'll say is 1, 5 is the solution to the system because it makes both values true. Or both equations true. So graphically we can find points of intersection, but we want to look at other methods of doing this. So to solve systems of equations, for right now we're going to introduce three methods. The first one is graphical, which we just did. The second one is going to be using something called substitution. And the third one is linear combination. Okay, well, that's it for now.